Hello everyone, I'm Divya, your math facilitator. So in this class, let's have a quick one-shot revision of tangents and secants to a circle. So I'm going to very quickly revise the entire chapter. Now in this chapter, you also have constructions, how to construct a tangent to a given circle. So that constructions part, I'll take it as a separate class before your exam day. Okay, so that is before your max exam day, you will have a separate class on constructions and also how to draw graphs, because constructions one compulsory question and graph is one compulsory question. So two important and simple concepts, so that I'll take it separately. Okay, before your exam day. Now today let's complete tangents and secants, the concept of this chapter, because you are all very tensed about this chapter. So I just wanted to teach you this chapter with very limited problems in a very short time. Okay, so that you can spend your time in other chapters. Okay, so firstly, this chapter has two important theorems. So theorem number one, okay, it says that radius and tangent are perpendicular. Theorem 1 says that radius and tangent are perpendicular at the point of contact. Okay, they are perpendicular at the point of contact. Clear? So now if a circle is given to you, okay, and if this is the center of the circle and this is the radius, okay, and I am drawing a tangent here at this point. Let this be point O, point P. So from point P you are drawing a tangent. So tangent passes through one single point. So now this tangent, okay, and the radius are perpendicular to each other at this point of contact. So this angle, if I take it as x, angle OPX is 90. So this is theorem number 1. Very important. Okay. Now theorem number 2 says that, theorem 2 says that length of tangent, okay, length of tangent drawn from external point, are equal. So firstly, if you just see, okay, here in theorem number 1, we are talking about the tangent and the radius at the point of contact, which is the point is on the circle. So this theorem represents on the circle, the point on the circle. Okay, in the second theorem, this is an external point. Now, if I take a point inside the circle, I cannot have a tangent. Okay, if I have a circle, if I take a point inside the circle, this will not be a tangent, this will be a secant. So, I can only draw a tangent from external point or from a point outside on the circle. Okay, so have a look here. From a point on the circle, I can draw a tangent, or from an external point, I can draw two tangents. Okay, so this has to be a tangent. Okay, and the length of tangent, if you see here, so this is the point of contact, this is the point of contact. Okay, here for these two, for the tangent drawn from this external point P, PT is one tangent, PS is one tangent. This is a point, brown color point. Okay, so the distance between the external point to this point of contact is called length of tangent, and the distance between this external point to this point of contact S is called length of tangent. So theorem 2 says that lengths of these two tangents are equal. Okay, and let me explain you this in very detailed way. Okay, so have a look here now. So suppose if I have a circle, okay, suppose if I have a circle and if I have an external point. Now from this external point, I can have two tangents to the circle. Okay, so let this be one tangent and let this be the other tangent to the circle. Okay, so I'm just moving my external point. So this is the external point. Is it very clear, everyone? Right? So now this is the radius. Okay, and sorry, this is the center and this is a point of contact. Let me take it as A. This is a point of contact of the tangent. Point of contact is nothing but the point from where the tangent is touching the circle. Okay, and this is the external point. Now PA is one tangent, PB is one tangent, and from this theorem, PA equals to PB. Length of external tangent are equal. And if OP is the line joining the center and the external point, Listen to my words. OP is a line joining the center and the external point, and OA is the radius. OA is the radius of the circle. We know radius and the tangent at the point of contact are perpendicular from theorem 1. Here also if I take OB is the radius center to any point on the circle. Now this radius and this tangent are perpendicular at the point of contact. You can see OAP and OBP are two right angle triangles. So this is one right angle, this is one right angle triangle. And also OA equal to OB, because they are radii of the circle, and you can see OP is the common side. Okay, and angle A and angle B are 90 and 90. So using RHS congruency, okay, I can say that these two triangles are congruent. If you want, I'll write the steps. So in the two triangles, triangle OAP and triangle OBP, okay, so you can see OA equal to OB and OP equal to OP, the common side, and angle OAP equal to angle OBP, which is equal to 90 degree. So using right angle, this is right angle. OP is actually the hypotenuse, opposite to 90 degrees hypotenuse, and this is one side. So using RHS congruency, I can say triangle OAP is congruent to triangle OBP. So when the two triangles are congruent, what can you say about these two angles? Now this is very important theorem I am telling you, because any question if it is given to you, you will be able to answer. Okay, so what about these two angles? Since the two triangles are congruent, okay, by CPCT, corresponding parts of congruent triangles, I can say these two angles are equal. Okay, so angle APO is equal to angle BPO. Okay, so these two angles are equal. So suppose if this angle is given as 30, so this angle is how much? It should also be 30. Did you understand now? So now next point is also these two angles are equal. Okay, angle AOP is equals to angle BOP. So if this is given as 60, this is also 60. Okay, they are equal. So you should understand. Just remember this. Now you will not prove all of this in the exam again. You will just remember whatever I am saying. Okay, these two angles are equal at the center. These two angles are equal at the external point from where you are drawing the tangent. Okay, and also there is one more important point here you have to remember. Okay, so angle AOB, okay, this total angle AOB plus angle APB, this total angle, okay, these opposite angles, sum is equal to 180. So you will remember this. Okay, so suppose in the exam if they give you angle between the tangents is 60, okay, if this angle between the tangents means this angle between these two tangents, this is the angle, isn't it? So if this is 60, then what is the angle between the two radii? This angle. So if this is 60, this will be 180 minus 60 using this point. Okay, so do remember, these are the only points you have to remember. Constructions I'll tell you separately, and also MCQs also. Before the exam day, I'll give you the MCQs of this chapter. So as of now, we are only doing the important questions which you can expect in your exam. Only the important. Okay, so this is the concept, and these are the important points you have to remember. Alright, so let's proceed. The first question, if a quadrilateral ABCD is drawn to circumscribe a circle. Quadrilateral is circumscribing a circle. Okay, this quadrilateral, there is a quadrilateral which is circumscribing a circle, which means you have a circle inside a quadrilateral. Do you understand now? So if they say quadrilateral circumscribing a circle, which means quadrilateral is outside, circle is inside. Okay, so if this is a circle, I'll have a quadrilateral which is circumscribing the circle. So something like this. Okay, do adjust with the figure. I don't have any tools to draw here neatly. Okay, so now let me take the quadrilateral is ABCD. Okay, I'm just assuming the quadrilateral as ABCD. Now this is a point of contact, isn't it? Let me take this as P. This is also point of contact Q. This is point of contact R, and this is point of contact S. Now if you just consider this part, So this is like a circle with an external point and two tangents are drawn here. Just see here. This is like a circle with external point, two tangents are drawn, isn't it? AP and PB. Similarly, here also A is external point to the circle and AP and AS are tangent. So can I write AP equal to AS using the second theorem? Length of tangents are equal. Again, you can see B is the external point to the circle and you have BP and BQ as tangents, and you know BP equal to BQ. And here the common mistake what you do also I'll tell you. So C is an external point. From C you have again two tangents CQ and CR. So I can write CR equal to CQ. And D is also an external point. From D you have two tangents DR and DS. So I can write DR equal to DS. Now you got four equations. So what you are going to do is you will add all the four equations. So adding equation 1, 2, 3 and 4. So what do you get? Adding all these equations, you get AP plus BP plus CR plus DR. So all the LHS side I am adding AP plus BP plus CR plus DR equals to AS plus BQ plus CQ plus DS. Now what is this part? See here, this part AP plus BP. AP plus BP is nothing but total AB plus CR plus DR. CR plus DR is total CD. So this is equal to, now AS plus BQ plus CQ. BQ plus CQ is total BC. So this is total BC. And also AS plus DS. AS plus DS is total AD. So you got whatever you have to prove. See, AD plus BC, AB plus CD. Right? So very simple step. Now here the common mistake you do is, wherever you are writing AP, the same place you should write BP. Okay, so you should not write like this, AP equal to AS. So you cannot write BQ equal to BP. If you are writing BP and AP on the opposite sides of your equation, you will not be able to add. So why are we writing on the same side? So that when you add, you will get it as AB. Okay, and also CR and DR, you should write it on the same side. Okay, AS and DS, you should see that they are on the same side. BQ and CQ, you should see that they are on the same side, which means this AP and BP should be on the same side. BQ and CQ should be on the same side. So this care you have to take before you are writing, otherwise you will not get the statement you want and you will be very tensed in your exam hall. So this trick you just follow. Okay, let's proceed to the next question now. Prove that the parallelogram circumscribing a circle is rhombus. Suppose if I have a parallelogram circumscribing a circle. So who is inside, who is outside? Parallelogram circumscribing a circle. So parallelogram is outside. Whoever is circumscribing, they are outside. So parallelogram circumscribing a circle. So parallelogram is outside, circle is inside. So this question is actually the continuation of the previous question. So if this is a parallelogram, let me take a circle. Okay, so this is a circle. So I have a parallelogram circumscribing a circle. Parallelogram I am taking it as ABCD. Point of contact as PQRS. Okay. So now again the same steps we will repeat. Okay. What are the steps clearly? So AP equal to AS. Okay. AP equal to AS like the previous problem. Now BP equal to BQ. BP equal to BQ. See, wherever you are writing AP, if it is on left hand side, you will write BP also on left hand side. Now I wrote BQ on left hand side. So CQ also I need to write on left. Sorry, BQ I wrote on right hand side. So CQ I should write on right hand side. So CQ equal to CR. CR is on left hand side. So DR is also on left hand side. So DR equal to DS. Now adding all of this, same like the previous question, you get AP plus BP plus CR plus DR equals to AS plus BQ plus CQ plus DS. So here I can write finally AB plus CD equal to what is this? AD plus BQ plus CQ is nothing but BC. So till here it is same to, like the previous question. Exactly the same steps. But after this what you will do is, since it is a parallelogram, okay, since it is given, since ABCD is a parallelogram. What is the property of a parallelogram? We know that in a parallelogram, opposite sides are equal. So AB equal to CD and AD equal to BC. Opposite sides are equal. AB equal to CD and AB equal to BC. So can I replace it here? So this is the final answer I got. So here let me replace. So therefore, AB plus CD equal to AD plus BC. This is what you have. Now here in the place of AB I can write CD because AB equal to CD. So AB plus, in the place of AB I wrote what? CD, because AB equal to CD. So CD plus CD equal to, in the place of AD what can I write? I can write BC. So CD plus CD equal to BC plus BC, or 2CD equal to 2BC, or I can write CD equal to BC. 2 gets cancelled. Did you all understand this now? Till here it is same like the previous question, but after this, since it is a parallelogram, opposite sides are equal. So again I am taking the statement, in the place of AB I am substituting CD, in the place of AD I am substituting BC. If you want in the place of CD you can substitute AB, no problem. ఓకే, ఇట్లానే చేయాలా మేడం అంటే మీ ఇష్టం. మీరు ఇక్కడ I have substituted in the place of AB, I substituted CD. If you want AB, you can write as it is. In the place of CD, you can substitute AB. Okay, then what will you get? You will get AB equal to BC. Whatever it is correct. Okay, now the final step, see. So we know that, see here, the last step is, we know that AB equal to CD. Yes or no? But CD is equal to what? CD equal to BC now. You have proved CD is equal to BC. But BC equal to what? BC is equal to AD. So what is happening to all the four sides? They are equal. So therefore, ABCD is a rhombus. Since all the four sides are equal, it's a rhombus. Okay, if all the four sides are equal and if the angles are 90, 90, 90, then it is a square. Okay, but here since it is a parallelogram, not necessary that the angles are 90. So hence we conclude that since all the sides are equal, it's a rhombus. Okay, next question. These are the important models I am telling you. Very limited questions I brought to you in the session. Now the tangents making an angle 60 degree between them. So it is 60 degree between the tangents. So this angle is at the external point. Okay, angle between the tangents is nothing but at the external point. Okay, so let me take this point as B, are drawn to a circle of radius √3. So the radius of the circle is √3. Find the length of each tangent. Length of each tangent. You can find the length of one tangent, you will get the length of the other tangent. Yes or no? So firstly, let me just join center to the external point. Now just now I gave you one theorem. Here I gave you lot of explanation here. What did I tell you? So these two triangles are congruent to each other. And what about these two angles between the tangent? If I am joining the line between the center and the tangent, these two angles are equal. Yes or no? APO equal to BPO. I told you it is very important, right? So we are going to use it now. Okay, now if I am joining this, if you want, I'll join this also. So these two triangles are congruent. You know why? We have already proved. Total angle is 60. So can I say this is 30 and this is also 30? Can we take it as 30 and 30, right? And we also know that radius and tangent are perpendicular. Now triangle OAQ is a right angle triangle. Yes or no? It is a right angled triangle. So in a right angle triangle you have something like this. Okay, so this is 90. Which is 90? Angle A. It is 90. You have O, you have P. Okay, so sorry, OQ is the external point. So opposite to 90 degree, this is the hypotenuse. So OQ is the hypotenuse. Okay. And what is this angle you got? This Q you got it as 30. This is 30, yes or no? This small angle. It is 30 in this triangle. Total is 60. You know these two angles are equal actually. These two angles. So this is 30 and the other angle. This is also 30. So now this is 30 and you have OA is √3. Now can you use trigonometric ratio to find the length of the tangent? What is the length of the tangent? Is nothing but AQ is the length of the tangent, or BQ is the length of the tangent, isn't it? The distance between the external point and the point of contact. This point also didn't I tell you in the starting of the session? So I need to find AQ now. This is the length of the tangent. So now which trigonometric ratio should I use? See, I have one angle given to me. So with respect to this angle, this is the opposite side, this is the adjacent side, this is the hypotenuse. I know what is opposite side value, it is √3. I have to find adjacent side value, which is nothing but my length of the tangent. So Let me take opposite upon the adjacent side equal to, opposite upon adjacent is what? Tan ratio, and the angle given is 30. So tan 30. Opposite upon the adjacent is tan. So tan 30 I am taking. Okay, why did I choose only opposite and adjacent? Because opposite side value I have, adjacent side value I want to find. So I have work only with these two. So opposite side is given as root 3 divided by AQ is equals to tan 30. Now what is tan 30 value? It is 1 by root 3 is equals to root 3 by AQ, or from this can I write AQ is equals to cross multiply, it is 3 centimeter. This is given in centimeter, so this is also centimeter. AQ is 3 centimeter. So if AQ is 3 centimeter, what is BQ? So therefore BQ is also 3 centimeter because length of tangents are equal. So here you will write the reason in exam. You will write, since the length of tangents, the second theorem you will write, the length of tangents drawn from external point are equal. So always this reason will fetch you more marks. And also before your exam day, you will get paper presentation tips. You will get how to present your maths paper, and not only that, you will get MCQs and important questions for science, biology, physics also I am planning, but these two I can promise right now. Not only that, so you will get lot of MCQs right from 2 p.m. You will have, classes in our channel. You will get MCQs. You will get important questions of all chapters again. Okay, and short questions which you should not miss. Like pre-final I gave you the definite questions which you should not miss, and some of you have commented and texted me that you got 79 marks, 78 marks, 75, 70. So great that you got those marks. So this time also I'll tell you what to prepare perfectly. Okay, so let's proceed now. From O point P, it is from a point P. Okay, so few mistakes you have in your Abhyas Deepika, spelling mistakes like this. From point P, from external point P, so this is the external point P, which is at a distance 13 centimeter from the center. External point P is at a distance 13 centimeter from the center. This is the center. So this distance is actually given as 13. The distance between the center to the external point is 13. Radius of the circle is 5 centimeter. So this distance OQ is 5 centimeter. Did you understand? The distance between the center and the external point is nothing but this OP. It is 13 and radius OQ is 5. Okay. So now tangents PQ and PR are drawn. PQ is one tangent and PR is the other tangent. So then find the area of the quadrilateral. You can see that this is a quadrilateral, QORP. This is a quadrilateral, isn't it? So you have to find the area of the quadrilateral. And do you remember I also discussed one point with you? Sum of these two angles is how much? 180. Okay, so it is also very important while I teach you objective before the exam day. So again I'll discuss all these points with you. Okay, very important. So now you need to find the area of this quadrilateral. Area of this quadrilateral, see, if I divide this quadrilateral, if I join OP as we have joined here, OP is 13, this is 5. So this quadrilateral OQPR or PQOR is actually divided into two triangles. Yes or no? And these are two right angle triangles. Why? Because we know radius and tangent are perpendicular, radius and tangent are perpendicular. So if I want to find the area of quadrilateral, PQOR, simply can I find the area of triangle OQP and area of triangle ORP and add both of them. So to find the area of this total quadrilateral, I'll find the area of this triangle, area of this triangle, add both of them, you will get the total area of the quadrilateral, isn't it? So now that is equal to, what is area of this triangle? Area of this triangle, this is a right angle triangle. We know area of a triangle is half base into height. So here also it is half base into height ORP. But what is base, what is height? See here. Always remember, wherever you have your 90-degree angle, this is 90-degree angle at point Q. This is hypotenuse. This will be base and this will be height. Or this will be base and this will be height. but you can see always your base and height is these two only. Okay, other than these two you cannot have hypotenuse as your base or height. So these two arms of the right angle triangle, these are called arms of the right angle triangle. So these arms of the right angle triangle are base and height. Okay, so here half, see here I can take OQ as base, and this is the other arm of the right angle triangle QP. So this is the height plus half. See, I can take OR as a base again, and this is the other arm. What is it? PR. Because you know OP is the hypotenuse, so hypotenuse cannot be base and height, isn't it? So till here is it clear? So that is equal to half. I see here, I think I can take these two common. Have a look here, I can take half. OQ and QR are actually the same. So if you want, you can take, otherwise you can directly substitute the values. Okay, so it's your wish. So half into OQ is 5. If OQ is 5, what is OR? OR is also 5, because OQ and OR are equal, multiplied by QP. Now what is QP? QP we did not find still. You have to find QP. Plus half, OR is also 5 into PR. Since OQ equal to OR equal to 5, it is radius of the circle. This reasoning is very important for you to write in the exam. Otherwise here above you have to write given OQ is radius, so that is equal to OR is also radius. Okay, and you have to find the area of quadrilateral PQOR. It is equal to area of these two triangles. So all these steps are very important. Now, so if I consider this triangle, okay, if I am considering this triangle QOP, it is given OP is 13, isn't it? OP is 13 given to you, and OQ is 5, radius of the circle. You have to find QP, and this is 90. Can you use Pythagoras theorem? You can say OP square is OQ square plus QP square. So from here I can write QP square is equal to OP square minus OQ square. So that is equal to, can I write it this way? OP is 13, so 13 square minus 5 square. So 169 minus 25, so I'll have 144. So this is QP square, or I can write QP is root 144 is 12. So QP is 12 centimeter I can take. Okay, so if QP is 12 centimeter, if QP is 12 centimeter, if length of this tangent is 12 centimeter, what about length of RP? It is also 12 centimeter, because we know length of the tangents are equal. So therefore QP equal to RP equal to 12 centimeter. Why? Again you will write the reason here. Length of tangent from external point are equal. So these reasons will fetch you marks. Okay. Okay. So now let us substitute this point here. So I am going to substitute here. So therefore area of quadrilateral, what is the quadrilateral? PQOR, isn't it? PQOR, right, is equal to, this is the step, isn't it? So half into 5 into QP is 12 plus half into 5 into PR is also 12. So you get the final answer as 12 ones are 12 6 are, so 30 plus this is also 30. So 30 plus 30 will give you 60 centimeter square. Don't forget to write the units also, it is very important. So it is given in centimeter square, you found it out in 20 centimeter square. Okay, so all the steps are really important. Please make a note of all these steps, right? Now let's proceed to the next question. In a triangle ABC is drawn circumscribing a circle. AB is 13. AB, this total AB. Okay, so let me write it this way. AB is 13. So BC is 14. The total BC is 14. AE, this is 7. Okay, so you have to find AC, the total AC I need to find. So firstly, to find AC, firstly, have a look here. So if AE, see, A is an external point. So from external point, I have two tangents, AF and AE. So can I say AF equal to AE? So if AE is 7, AF is also 7. So this is 7. Now AB is given as 13, but AB you can write it as AF plus BF. The total AB I can write as AF plus BF. So this is 13. So AF is given as 7 plus BF is 13. So BF I can write it as 13 minus 7, or it is 6. All are in centimeters. Okay, so BF value I got it as 6 centimeter. This is 7 centimeter. So if BF is 6, okay, so now from external point B, you know BF and BD are equal. So BF equal to BD. So if BF equal to BD, what can I say? BF is nothing but 6, so BD is also 6. So BD is also 6 centimeter. So this is 6. Now again, BC is nothing but 14 centimeter. BC you can write as BD plus DC. This is 14. So BD is 6 plus DC is 14. So DC, can I write it as 14 minus 6, or DC is nothing but 8 centimeter. Got it? So if DC is 8, we know from external point C, CD equal to CE. So CD or DC is same, isn't it? So you got it as 8. So CE is also 8. So therefore CE is 8 centimeter. But what you have to find? You have to find AC. So AC is equals to AE plus EC. AE is 7 centimeter plus EC is 8 centimeter. So this AC is total 15 centimeter. Did you understand? So step by step we are going. Okay. So when you are writing this, write A is external point. Okay. So length of tangent from external point are equal. So here also BF equal to BD. So from B you are taking. So B is external point. Okay. And length of tangent from external point are equal. Here also C is external point and length of tangent are equal. Everywhere explanation is very, very, very important. The reason which you write in bracket is really important. Is it very clear? So firstly we started from this point. AE is given as 7. So if AE is 7, AF is 7. Out of total 16, if AF is 7, FB is 6. If FB is 6, BD is also 6. Out of total 14, if BD is 6, then this is 8. Now if CD is 8, CE is 8. Okay, so you are coming in cyclic order. So AE, AF, BF, BD, CD, EC. Here, and total AC is nothing but AE plus EC. Right, beta? So that's all. These are the very important models. Apart from these models, let me tell you, you have MCQs, which I'll do it separately, and you have construction, which are really important. These few questions which I told you are utmost important, maximum important. So please don't miss any question. Similarly, the most important questions of progressions, and what is the other chapter you asked me? Quadratic equations, and if there is any other chapter you want me to make also, I will definitely make. Please do tell me here in the comment box, and I hope this session is useful for you. If you are subscribed to the channel, these exam time I will definitely be with you. You will have marathon sessions for your MCQs of maths, most important questions of 8 marker, 4 marker of maths, and SST, biology, MCQs, most important questions. All of this you will have in the channel, along with your next whoever are going to take your polycet coaching, you will have that as well. Okay, so don't forget to subscribe the channel, like the video so that even I get encouragement, and share it with all your friends. Okay, and definitely comment and let me know. Right, so I'll see you all in the next session. Bye bye, take care.